Okay. So once you click that, there will be many related software of the Aspen one. Like this is Aspen Basic Engineering version 8.8, Aspen Plus V8.8, and Aspen Properties, Aspen SLM, Aspen Utilities, Aspen Tech. But the related to you is Aspen Plus. This one, Aspen Plus version 8.8. So if you click on that, there will be so many files, but this is A plus. The sign is A plus. So if you click on that, you can pin on the start like I have done that, this one. So if you click that software, this is a very heavy software, so it takes time. So now you can see uh, it will give you option that you want a new file or you want to open some already file which you have already created. So in your case, obviously you will click on the new file. So if you click on the new file, you will see this window. So it asks you that do you want a blank simulation or out of these folders like solids, refinery, polymer, pharmaceutical, metallurgy, gas processing. So these are the templates for various category because there are so many fields the people are working. So I mean you can use their already built format. So in your case, let's say you want to create a blank simulation, so click on that and then create. So here is a button create. So if you create that, then it will open. So this is the window after it will open. So here on the left side, in this way you can see there are four modules. One of the modules it calls a properties, and then is a simulation, then is the safety analysis, and the fourth one is energy analysis. Now related to you is the first two module, properties and simulation, right? We'll not discuss safety analysis or the energy analysis. We'll just do properties and the simulation. So let's start from the basic. The first file, first folder, it's called the setup. So if you click on the setup, there will be specification. So first of all, you need to mention, for example, you need to give some title of your file. Let's say you are working, let's say refrigeration system. Let's give the name refrigeration system, right? And then it asks you about the global unit set. I mean, which units you are going to use. For example, ENG mean English units, MET mean metric engineering units, right? This is the user defined units. I mean, you can set your own units. And the last one is, let's say, international system units. So let's say we want to work on the user defined, right? We want to change our own units. So let's say I have selected this one, right? And then it asks what are the valid phases, right? You can keep it as it is. No need to, I mean, disturb this folder. And then is the calculation option. In this calculation option, sometimes let's say I mean the water is not 100% pure, so you can give some minimum of water composition in water phase, let's say 98%. And sometimes if you're performing the exergy analysis, right, exergy analysis is always performed with reference to the environment condition, that what is the environment temperature. Let's say in terms of centigrade, you can put, let's say, what is the environment temperature and what is the environment pressure. Here is 25 degrees C and about 1 atmospheric pressure, but you can change the reference condition in case you are performing the exergy analysis. But in our case, we are not performing the exergy analysis, so let's keep it as it is. Now you can see some red. The red one says this is incomplete, so you have to complete those red, I mean this circle. Red circle shows that this information is incomplete. So if you click on the specification, in specification it asks you the component ID. I mean in your system, which component you are going to use. For example, are you going to use air, are you going to use water, or some refrigerant. Let's say we take some example. For example, our subject is a refrigeration system. So let's say we select some refrigerant. We want to work on some refrigeration system. So let's say here we can find. If you click on the find, then that means you need to define some component. uh, you type some of the component. Let's say any refrigerant. Name any refrigerant. Let's say R12. So let's say I type here R12 and then enter. So related to R12, it will search out all the available components. So can you see related to R12? I mean, this is the first one is R12, then is again R12, but it is also 1, 2, 5, 1, 2, 3. So related to R12, it has search out from its directory. So the first one, when its full name is, I mean, if you see the full name, this is dichlorofluoromethane, right? And its formula is a CCl2F2. So let's say you click that and you double click that, so it will come here. Then you can close that. So this is the, I mean, your working fluid. This is your working fluid that will be used in the refrigeration system, right? And then you can see another red. Here is another red, right? And if you click on that, I mean on the red, so it asks you methods. I mean, which property method you are going to use. I mean, in property method, you know that there are so many properties method. I mean, one of the property method is ideal gas. Whether, I mean, the refrigerant that you are going to take, whether you want to take it as an ideal gas or the real gas or the actual properties. So we want to use the actual properties. So actual properties, they are based on the property we call Peng-Robinson method. There will be Peng-Robinson method. If you search out that Peng-Robinson method, it will be here. Peng-Robinson method. It will be, yeah, this is PENG. So you can see this is Peng-Robinson equation of state. I mean, how you calculate the pressure, volume, temperature, enthalpy, all these properties, they are based on some background equation of state. Equation of state, you know that PV is equal to ZRT or MRT. So these properties will be computed based on some equation of state. So in this case, we'll select Peng-Robinson equation of state. Now you can see the red is now turned into blue. So that means the information is complete. Even here you can see, I mean, at the bottom, it is written required properties input is complete now. So that means all the properties that are required for the simulation or for the modeling or for the design, they are completed now. The next step is, I mean, the second one. This is called the properties. The properties table is now completed. You can see this information that required properties input is complete now. The second is the simulation, right? If you click on the simulation tab, then the new window will open now. Right? This is called the main flow sheet. It is called main flow sheet. So in flow sheet, I mean, you have to develop your own model, right? First of all, this is the first tab. It says whether you want to use a material, whether you want to use heat, work, right? So in our case, we are going to use the material now. But before that, we have to develop some. But before that, we have to develop the model first. Excuse me, there is a background noise. Please mute your mic. Who is there? 077. All right. So in this worksheet, we have to develop the model first. Let's take an example. Which model we should develop? Let's you told me which model. Let's say we want to develop a refrigeration system, right? And there are so many types of the refrigeration system, like the we just study air refrigeration system, vapor absorption refrigeration system, right? Vapor adsorption refrigeration system, and the most familiar one is vapor compression system, because vapor compression system is the simplest one. It consists of evaporator, compressor, condenser and the expansion valve. So let's say we want to develop the vapor compression refrigeration system. So in vapor compression refrigeration system, there are four components. You can see here there are so many components. One we call the mixer and splitter, right? In mix, this is for the splitting any stream, right? And this is the separator. I mean, if you want to separate two of the component, I mean, at the inlet you have one component and you want to split into two component, and then is the heat exchanger. So there are so many types of the heat exchanger. This is simple heater. Then this is the, I mean, you can see shell and tube type heat exchanger. There are so many design available for the heat exchanger. You can see that. And then there are columns. There are different types of the columns. Then there are reactors, many types of the reactor. Then there are many pressure changer mean which increases the pressure. For example, the pump increases the pressure of a liquid, compressor increases the pressure of a gas or air. Similarly, we have valves also decrease the pressure because they are just like a restriction. So valves, I mean, combinedly they called pressure changers, and we have some other component as well. So that means in our system, let's say for vapor compression refrigeration system, what we need is we need an evaporator, compressor, condenser, and expansion valve. So let's try to develop our own model. So first component is, let's say, start from the evaporator. So which component I should select for the evaporator? What do you think? For evaporator, which component I should select from here to model the evaporator?
So heat exchanger.
Heat exchanger, right? So let's say I have selected this heat exchanger. So this is my evaporator. So when you click on that, it asks a name. Let's give the name EVAP. That will indicate that this is an evaporator, right? So this is an evaporator. Then after evaporator, what we have? Compressor, right? So that will be pressure changer. So let's say this is compressor, right? So let's give COMP. So that's, let's say, compressor. So here is a compressor. Then after compressor, again we have a condenser. So condenser again is a heat exchanger. So let's say this is a heat exchanger. So let's say this is a condenser, COND, that means condenser. And then we have the expansion valve. So expansion valve will be from the pressure changer. So this is a pressure changer. So from this pressure changer, I can select a valve here. Let's say this one, throttle, THROL, that means throttling valve, right? So let's say this is throttling valve now. Now, these are the four component of my vapor compression system. This is the evaporator, this is the compressor, this is the condenser, and this one is throttling valve. Right now I have to connect this. Right, so I'll use, I mean, there are different three options available for the connection. One is that whether you want to connect through a material stream. So this is a material stream. The next one is the heat stream. The other one is the, so obviously we will connect this through material stream. So if you use that material stream, let's say from evaporator, outlet of the evaporator to the inlet of the compressor, right? Let's say this is 1. You have to give the name 1. Similarly, from outlet of the compressor to the inlet of the condenser, right? Let's say this is stream 2, right? And then from the outlet of the condenser to the inlet of the valve, right? Let's say this is 3. Right? And then from the outlet of the valve to the inlet of the compressor. So our system will be completed. Let's say this, you can give any name, right? And you can rotate this, I think. Yeah, rotate. Here is option rotate. It should be to the right, I think, right? So I have rotated this one. And similarly, it can be rotated from this way. Yeah. And similarly, it can be rotated. Yeah. Now it's look better. So that means this is our evaporator, this is compressor and condenser, and then the throttling valve, and then the evaporator. Now, can you see the red one now? So that means there are many incomplete information now. I mean, we need to put information about the compressor, condenser, evaporator, right, and as well as the throttling valve. So let's try to put the information about the compressor. So in this it asks you, I mean, there are two options, whether you want to use this component as a turbine or a compressor. So obviously we want to use it as a compressor. And in compressor, what type of compressor you want to use? This compressor will be isentropic compressor. You want to use isentropic using ASME method or GPSA method. So there are many. You want to use it as a positive displacement compressor, positive displacement using piecewise integration. So let's say we want to use it as an isentropic compression. Then for compressor, what are the outlet specification? I mean, you can select any of these specification. Let's say we want to use discharge pressure. Okay, how much discharge pressure you want to get from this compressor? So let's say we want the discharge pressure, let's say 3 bar. Put it as 3 bar, right? And then here it asks you the isentropic efficiency. So what should be the isentropic efficiency? Similarly, what should be the mechanical efficiency? Let's say this is 100% isentropic. Let's say mechanical efficiency is 1. I mean, I'm just assuming, right? So now you can see the information related to compressor is now blue. I mean, from red to blue. Then is the second one, condenser. That means we also need to put information about the condenser. So which information is appropriate for the condenser? Let's say there are many. I mean, what we want in the condenser? What do you think? What we want in the condenser? Anyone? What we want in the condenser?
Phase change.
Yeah, we want phase change from vapor.
Vapor
I mean, inlet पे vapor होता है and it should be outlet पे क्या होना चाहिए?
liquid.
Liquid होना चाहिए. So that means this is a flash type. So which flash type we want? We want flash type as a vapor fraction, right? We want the vapor fraction here, right? And similarly, I mean, let's say one is the pressure, another one is, let's say, vapor. Sorry, let's change this as a sorry, this is, let's change it as a vapor fraction, and this one as a pressure. No, this one as a vapor fraction. Why? All right. So it's asking for the uh, flash type. So flash type is vapor fraction. So how much vapor fraction you want to get, or the pressure you want to get? Let's say this is the pressure tab, this is the vapor fraction tab. So how much pressure do you want to get? Any pressure drop in the condenser? If you don't want to get any pressure drop, then you can put 0. So if you want to get some pressure drop because of the flow, then you can put the pressure there. So let's say I'm assuming that there is no pressure drop in the heat exchanger, in the condenser. And what should be the vapor fraction in the condenser? What should be the vapor fraction in the condenser? It should be it should be it should be 0. Why it should be 0? Because in condenser we want to convert from vapor to liquid. So that means our objective is to convert all of the vapor after compressor into liquid, right? So that means we have to put vapor fraction value equal to 0. Right? Then again, this is blue now. The second component is evaporator. So in case of evaporator, again, we need to put values. So what we want in the evaporator? We want in evaporator to absorb heat, and then from inlet the liquid will be converted into vapor, and we want to make sure that at outlet of the evaporator there are all vapors, there is no more liquid, because if the liquid enters into the compressor it can destroy the compressor. So here we have to select the vapor fraction, and how much vapor fraction? 100%. And what about the pressure drop? Let's say no pressure drop in the compressor. Okay, the last component is the throttling valve. So what about the throttling valve? How much outlet pressure we want in the valve? What is the inlet pressure in the valve? What will be the inlet pressure in the valve? हमने कितना डिस्चार्ज में किया हुआ कंप्रेसर में? मीन कंप्रेसर में 3 बार होगा, 3 बार प्रेशर कंडेंसर में से मूव करेगा, तो थ्रॉटलिंग के इनलेट पे कितना आएगा? 3 बार। तो इसकी आउटलेट पे कितना आना चाहिए? वो डिपेंड करता है कि आप कितना ड्रॉप करते हैं प्रेशर। डू यू गॉट द पॉइंट और नॉट? Do you got the idea or not? I mean,
Yes,
Yes, sir.
let me draw that. For example, here, let's say this is a valve, but before valve, we have evaporator, sorry, condenser, and then the compressor. This is our compressor, right? And this is our evaporator, right? So here we have assumed that, let's say that this compressor will increase pressure up to 3 bar, right? And 3 bar, when it will enter in the condenser, there is zero pressure drop in the condenser, zero pressure drop in the condenser. So that means same 3 bar will move to the expansion valve, but now here it is asking how much the outlet pressure you want here, because if you recall the TS diagram of the vapor compression cycle. I mean, the first one was, let's say compressor. In compressor, there is isentropic compression, right? And then there is heat rejection in the condenser, right? And then there is throttling. There is throttling. Throttling is basically the pressure drop, and then there is evaporator. I mean the heat absorption, if you recall that. So I mean, what pressure should be dropped here? I mean, from 3 bar, this is the 3 bar pressure line, 3 bar, and how much this should be the pressure drop? So let's say this is 1 bar, right? So that means 3 bar, and because of this throttling process, the pressure at the outlet is, let's say, 1 bar, right? So we can put here, let's say the outlet pressure is 1 bar, right? So once you put that, you can see all the inputs are completed now, right? You can see that all the inputs are required inputs are complete now, right? And now we can give some, let's say, inlet condition now. I mean, I think since all the values are completed now, we can move this to next tab, right? Next it says all the required input is complete. You can run the simulation now or enter more input, right? Let's say we want to give some input condition. You can see here the flash type is vapor fraction, let's say. Okay, I'm in for material 1. I'm talking about material 1. And what is material 1? This is the material 1. I mean, you can give certain condition here at material 1. What condition you can give? Let's say, I mean, we can give that the flash, I mean, at outlet, the vapor is 100%. And what is the pressure? Let's say 1 bar pressure, right? And then it asks what should be the flow rate. Let's say the flow rate kg per second. We can select here where is kg per second. And this is more, I mean, mass. We have to select the mass flow rate. Then it will come out to be kg per second. So this is kg per second. Let's say 1 kg per second. And here it asks you that R12, what is the composition? So let's say mass fraction is 1. I mean, we are just using one component, so that means that will be 100% used. So now it says the information is complete now. Now we can run the simulation. So you can see here, this tab is for the next, this one is for the run, and this is for the reset. I mean, reset means you can go back to the initial condition. And after you run, there is a control panel here. That control panel, I mean this one, it will indicate you if there is any error or if there is any mistake, then you can see the mistake or error here. Then you can run the simulation, right? After you click on the run, it will run the simulation. So can you see here, warning, right? No error or warning were issued. So it says at the last that no errors or warning were issued during the simulation. That means our simulation is perfect, right? Then you can go back and you can see the results. Here you can see the results here, right? So this is the results for the throttling valve. This is the results for the evaporator, right? This is the results for the condenser, right? This is the results for the compressor, right? So you can see the results in all the streams. Okay. For example, let's try to see the results now. And these are the results for the stream. I mean, stream 1, these are the results for stream 1, results for stream 2, results for stream 3, and the results for stream 4. So let's see the results for stream 1, what it indicates. So you can see the results of the stream 1. So stream 1 means this one. This is the stream 1, outlet of the compressor. So what are the results? Result says that total flow rate is this much, and we are using R12, right? This one, the pressure is this much, and the temperature. Can you see the temperature? How much is the temperature? Minus 30 degrees C, right? Minus 30 degrees C, and vapor fraction is 100%. What is the enthalpy? Enthalpy is this much. You can also convert into your own units. I mean, from the setup, I mean, from the properties, there was specification. So we selected this one, and in units, we can change the units right here. Since we have selected the that's a calorie uh, for the energy, so that's why we have to change the units for that. Anyway, let's go back to the results. So this was the results for the stream 1. We can also see results for the stream 2, results for the stream 3, results for the stream 4. So all the 4 stream results we can see. For example, let's say try to check the temperature. So this was the temperature in minus 30 at outlet of the evaporator. Then this is the outlet of the compressor, 7 degrees C, then outlet of the condenser, then again outlet of the throttling valve. So all the stream, the temperature is there. Similarly, the pressure, we can set the pressure as well, the vapor fraction as well, all the properties, enthalpy, density, right, entropy, right. So you got the similarly, I mean, we can see the results of the blocks as well. I mean, these are the results of the blocks as well. For example, results of the compressor. These are the results of the compressor. For example, how much input power is required? The input power required is about 18.7 kilowatt. Right? This, I mean, you can select the motor for this compressor, 18.7 kilowatt, right? And what we assume that the isentropic efficiency is 100%. There is no power loss. For mechanical efficiency, we assume to be 1. What is the outlet pressure of the compressor? 3 bar. What will be the outlet temperature? 7 degrees C, right? Similarly, the results for the condenser. I mean, the results. These are the results for the condenser. So it says for the condenser, How much heat is rejected? This much heat is rejected to the atmosphere. Right? This much heat is rejected to the atmosphere, right? So this is pressure in the condenser. Which property method you have used? We have used the Peng-Robinson state, right? And this is the temperature in the condenser, right? Similarly, we can see the properties of the, the results of the other. This is for the evaporator. Right? These are the results for the evaporator and the throttling valve as well, right? So how much heat is absorbed? This much heat is absorbed in the evaporator. This much heat is absorbed in the evaporator, right? Now let's move back. So in this case, uh, we have simulated the vapor compression system. And which refrigerant we used? Which refrigerant we have used for?
R12.
Sorry,
R12.
R12. So let's say I want to check the results by using some organic refrigerant, right? Organic refrigerant, let's say propane is very famous. So let's say I want to use propane now. Instead of at R12, I want to use propane. So we have to change the uh, from the properties, we have to click on the properties and then we have to change the component. So let's say I have deleted this component and I want to select a new one. So find propane, Propane, propane. So where is propane? There are so many component here. We have to see the propane. Where is propane? Propane, right? So propane, C3H8. Now once I have used the then even I can change uh, the units. Let's say SI unit or this one, and I want to change those units. Let's say this one. No, let's say SI unit. But in SI unit, uh, the temperature is in degree C, pressure is in bar, and uh, and the heat is in calorie. I want to change the enthalpy value. Let's say I want to see the results in joule per kg or joule per kilomole, because normally the properties are given in terms of joule per kg. Similarly, enthalpy flow in terms of joule, uh, enthalpy flow is in terms of kilowatt, mass enthalpy is in terms of joule per kg, right? Heat in terms of kilowatt or kilojoule, right? Similarly, heat flux in watt per meter, mass capacity in terms of, let's say, joule per kg, right? Joule per kilomole per Kelvin, right? Kilojoule per cubic meter Kelvin, right? So I have changed the units now. Okay. And then let's say in simulation tab, I want to change now. Let's say instead of the 3 bar, I want the 10 bar here. That's a 17 bar here, right? And here, let's say the pressure, let's say up to 10 bar, right? That means here I got this 17 bar and the pressure drop is 10 bar, let's say. Okay. And let's say then it says required input is incomplete. Where is the incomplete information? I have to reset the value because I have changed some of the system. So it says if, and then you go to the simulation. So there are some incomplete information. Let's say input 1 is incomplete. It says because this is red, right? It says how much is the mass flow rate, and let's say the mass flow rate is kg per second. So let's say 1 kg per second. And how much propane you want to use? 100%. I mean, this is the fraction, mass fraction. So one mass fraction mean we are just using working fluid, propane we are using as a working fluid. Now you can see the required information is completed now. So now we can run the simulation. From here, we can run the simulation. I mean, from home, and then let's say run, and we can see the control panel. If there is any error, there is no error or warning issued during the simulation. So again, our results are ready. You can see our results are ready. Now, this is the simulation part. Let's say I want to work on the design part as well, right? So how to design based on your own requirement, right? How to design based on your own requirement. So there is a option. It is called flow sheet option, right? This is called flow sheet option, and you can see the design specs, right? This tab is called the design specs. In design specs, you can put your own design specs. Let's say let's say I want to get the outlet temperature of the condenser, let's say 35 degrees C. So let's say I want to get 35 degrees C outlet temperature of the condenser, right? This is my requirement, that I want to get the outlet temperature of the condenser as 35 degrees C. So what I can change, let's say I can change the compressor pressure. Let's say I can give a range that if I change pressure from, let's say 1 bar, let's say 5 bar to 15 bar, and the temperature of the outlet temperature of the condenser should be 35 degrees C. So that's called the design specification, that you can design according to your own specification. Let's say you click on the design specs and then new. You can give it as a name. Let's say this is design specs 1. You can give the default name, then you click OK. Once you click OK, then it says that you define the variable, right? What is a variable? What is the variable? Let's say this is a new variable. Which stream? What's the name of that stream? Outlet of the condenser. What is the name of that stream? Let's say that's the temperature. So let's say you give the name T3. Right? Let's say you give the name T3. Then what is that? Out of this category, what is that? Block, stream, model utility, property parameter, or it is a reaction. Which one is that? Outlet temperature of the condenser. What is that? Out of this option. that stream, right? That's a stream. So T3, you have selected a stream, and then what is that? That's a stream variable. Here is a stream variable, right? So which stream? That's number 3, right? That's a mixed stream. So which variable? Temperature. So that's a temperature. So I have defined it that I want to get a specific temperature. I want to get a specific temperature of stream T3. I mean, what is T3? This is T3, outlet of the condenser. So I want a specific temperature of this stream T3, right? So I have designed, I have given some specification, and then it says what are your specification. So what is my specification? My specification is T3, right? And what is my target temperature? My target temperature is, let's say, 35 degrees C. And how much tolerance I can, I can tolerate, let's say 0.1, up to 0.1 variable, I can accept the result, right? And then what do you want to vary? What you want to vary? You want to vary the pressure of the compressor. So what is that? That's a block variable, right? That's a block variable. And which block? Compressor, right? And which one? Pressure. You have to see the pressure. Which pressure? Outlet pressure. There will be P out. Please check that pressure out. That's a pressure. That's, if you can you see the specified outlet pressure? So let's say specified outlet pressure. So which range you can vary? Let's say from 5 bar to 15 bar you can vary, so that you can get the pressure. You can get the outlet temperature of the condenser as 35 degrees C. So you have, I mean, this is your first design specification. Now again you can reset, and then you can run, right? You can run. So the results is available, and you can see in the control panel there is just one warning, but there is no error, right? Now you can see the results. What are the results of design specs? So this is the results of design specs. So if you want to get the 35 degree C temperature, outlet temperature of the condenser, what should be the outlet pressure of the compressor? It should be 12.2 bar. It should be 12.2 bar pressure. Then you can get the outlet temperature of the condenser as 35 degrees C, right? So let's say I want to put another design specs, right? Let's say I want to put another design specs. Let's say I want to get the here, at 4, I want to get at 4 temperature. Let's say 10 degrees C. What is the temperature now? Let me see the temperature now. Now is 26, 26.89 degrees C, right? And I want to get more cooling, right? In the evaporator, I want to get more cooling, and I want to change the temperature here at 4. Let's say I want to get the temperature at 4, let's say 10 degrees C. Now is 27 degrees C. Now the temperature is about 27 degrees C, but I want to get this temperature as 10 degrees C, so that the evaporator can absorb more heat. So let's say then I have to define a new design specs here. Here, let's say design specs. Where is that design specs? Yeah, this one, right? And you new, right? So by default name is DS2. That means design specs 2. So what is this now? Again, my variable, you can give the name, that's T4, right? That's T4. You can give any name, but since this is the stream number is 4 and the T for temperature, so I want a specific temperature at inlet of the evaporator. So let's say this is T4, right? And T4, what is that T4? That's a stream variable. So I have to click on the stream variable. Then out of stream variable, again you have to select that this is a stream variable. Which stream? Stream number 4, right? And which variable is that? That's a temperature. TEMP mean temperature, right? In degree C. So I have defined that which parameter I want to get at point number 4. So which is the inlet of the evaporator. And then I have to I mean red says that your information is incomplete. So this is blue, so that means information is completed now. So let's move back. So what is your specs? That's T4. And what is your target? 10 degree C. And how much tolerance you can bear? Let's say 0.1 variation that you can accept. And which thing you want to vary? अब इसमें what will be our variable? What is the possible variable? Let's say here we want to get 10 degree C. So what could be our variable? What do you think? What could be our variable? Anyone? What could be our variable? So our variable could be the pressure, as I showed you here. I mean, let's say previously this temperature was 27 degrees C, right? This was our previously our temperature was 27 degrees C. So I want this temperature instead of 27, I want let's say 10 degrees C, right? So what I should change? That's my question. I should change the outlet pressure of the valve, the throttling pressure. So previously we have set the pressure, I think 10 bar. So now we'll give a range, right? Let's say for this one, I mean for that variable DS2, we have to vary the block variable. That's the block variable. And which block? Throttling, right? And which variable? Pressure, right? Where is P out? Outlet pressure, right? Outlet pressure in bar. So from which range to which range? Previously we have put the 10. Let's say we want to vary from 1 to 10, let's say, right? So now it is completed. Now we can go back to the main flow sheet. Let's reset the results and again simulate, right? So you can see the results are available from the control panel. We can see there any error? There is no error in the simulation. So now we can see the results. Let's say DS2 and the results is available. So it says if you want to get the 10 degree C temperature, then you have to take the 6.36 bar pressure at outlet of the the throttling valve. So previously the pressure, when the pressure was 10 bar at outlet, the temperature was 27, right? Now we want this temperature as 10 degrees C. So what should be the pressure now? The pressure should be 6.36 bar, right? 6.36 bar. 6.36 bar. Then you can get the temperature of the evaporator here 10 degrees C, right? So this is just the basic information. How can you design any of the variable? How can you design the complete system? Like this is an example of the vapor compression system. So similarly, you can model, you can design, you can simulate the other refrigeration system like the air refrigeration system or the vapor absorption refrigeration system. Like in air, what is the difference here? There will be first the a turbine, a compressor, same compressor. After compressor there will be heat exchanger, then after heat exchanger there will be, instead of the valve, there will be the cooling turbine, right? Instead of this there will be cooling turbine. So after cooling turbine there will be cabin where the passengers are sitting. So that will be like an evaporator. So similarly, instead of a valve you can just put a cooling turbine. So you can design and model the refrigeration system of the aircraft. Similar is for the vapor absorption system. So I hope you understand. In the next class, we'll do some more practice. But until that, you should install the software and you should do the same practice in your PC as well. You install that and you try to do the simulation. You try to change the variable because your CEP problem will be related to the software. I mean, the software will help you to solve your CEP. Right? Any question?
Yes, sir. Sir, is
Sir,
it possible to,
Yeah, one by one.
sir, is it possible to vary the compressor input as well?
Yes, you can vary. Let me vary. I mean, let's say, um, okay, for example, let's go back to the compressor. So here we have set the compressor pressure, let's say 17 bar. So let's say you can vary 14 bar, right?
Sir, I mean the power input.
No, the power input is based on your discharge pressure. I mean, I mean, one compressor you purchase from the market that can increase the pressure from atmospheric pressure, which is 1 bar, to let's say 14 bar. So that will have certain input power, right? If you want from 14 bar to let's say 50 bar, then obviously you need a very big compressor. So the input for a big compressor will be much higher. Let's say in this case, I mean, previously, let's say it was 17 bar. Let me show you. It was 17 bar, right? You run the setup and you got results for the compressor. So let's see the results for the compressor. So how much input is required? 30.29 kilowatt power is input is required for producing 17 bar pressure, right? How much bar pressure, right? For producing yeah, for producing 17 bar pressure. So what if I change the pressure? Let's say instead of 17, I change to 13. Then what happens? So now you can see again. Now how much is the pressure now? It's 30.23 2137, right? So accordingly, the outlet temperature is changed. When you change the outlet pressure, the outlet temperature will change. What is the outlet temperature that the compressor has produced? 37 degrees C. So let's say instead of 37, if you change the pressure here, let's say to 20, then what happens? So what happens for the results? It's the temperature is now 37. Instead of 30, now it is moved to 37, right? So even the outlet power is the different now. Actually, you have put the design specs, right? If you remove the design specs mean you will get always according to your design. So it will vary the outlet. I mean, if you look at the design specs, that's called the design specs. I mean, in design specs, you vary the compressor pressure. Okay, if you vary the compressor pressure from 5 to 15 bar, then what you want to get, you want to get the outlet temperature of the condenser as 35 degrees C. So you will always get 35 degrees C at the condenser outlet pressure, and it will tell you that how much should be the compressor pressure. So it will always tell you that this should be the compressor pressure. For example, in the results, it will say you should use 12.2 bar if you want to get 35 temperature at the outlet of the compressor. Okay. In addition to that, we can also see, let's say, uh, for example, if we change the pressure, right? If we change the outlet pressure, of the compressor, then obviously its input power will be different. Is that so? If we change the outlet pressure, let's say now we have put the outlet pressure 20 bar. Let's say how the pressure is changing and how the input is changing. We want to see that if you change, let's say pressure from, let's say 5 bar to 20 bar, then how the input is changing. How can we see that? Then there is another option for that. It is called sensitivity analysis. Can you see the model analysis tool? Right, so this is model analysis tool. So in model analysis tool, we have four options. One of the option is it called sensitivity analysis. And the second called optimization, constraint, and a data fit. So let's say in sensitivity analysis, if you click on the sensitivity analysis, let's say it asks you any name. So let's say we give the default name S1. Then it says the first one is variable. So which one you want to vary? Which one you want to vary? What you want to vary?
So the
You want to
pressure.
vary the pressure. Let's say that's called the block variable, right? This is block variable. And which block? Compressor, right? And which variable? Pressure. You will see a pressure here. PRE. Yeah, this one pressure. So you want to vary the pressure, right? From which range to which range? Let's say from 5 to 20. From 5 to 20, right? You want to vary the pressure and what output you want to see? Right? Let's say the first one is the, let's say, first one is pressure, compressor, COMP, compressor pressure, right? And that's a block variable. Which block? That's a block variable, and the block is compressor and the variable is pressure. This one, right? And then which results you want to see? You want to see the input power, which is required to the compressor. Let's say input power. And what is the input power? Uh, what is that input power? That's come under model utility, right? That's come under model utility, right? And that's come under model utility, right? And which is that? That's utility variable. Which block? That's a compressor. Utility variable. Which one? It's not showing the block. Why? So let's say you vary the compressor temperature pressure and how the temperature is, let's say, changing. Let's say you want to see the stream temperature and what is that's the stream variable. स्ट्रीम वेरिएबल विच स्ट्रीम कंप्रेसर के आउटलेट पे कौन सी स्ट्रीम है जी दैट्स नंबर टू सो नंबर टू stream number is number two which variable temperature so let's see temperature right so this is completed why it is red compressor no that's a block variable that was a block variable and that's a block variable and the block one is compressor right and the variable was pressure right and the units is already selected bar and then Okay. Why still it is red? Okay, we have to choose the number of points. Let's say number of points is, let's say 20. Okay, and the tabulated value, fill all variables, right? So now it is completed now, right? You can see all the blue one. So we can reset and we can run the simulation, right? So once you check the results, right? Can you see the results? So the result says, let me plot that results. Let me select this one, this this one and this one, and let me plot that. Okay, we have set the, sorry, I forget, we have put the design specs as well. So let me first deactivate that. This is deactivated, and the second one is also deactivated, and then we run again. It shows some error in the results because the first one is not possible. 2 bar pressure, outlet pressure of the compressor is not possible. So that means the possible pressure is from 8, above 8. So we have to change here the range of that. So it should be from, let's say, 9 to 20, right? So again reset and you again simulate, right? So what is now again, if you look at that, so these results are okay. You can plot that. For example, you copy or even you select the results curve here. It asks you, you want to plot between compressor and pressure and compressor temperature. Okay, right. So this is the, can you see, on horizontal axis there is compressor pressure. So if you vary the compressor pressure from 9 bar to 20 bar, how the temperature is changing. From, for example, 9 bar, at 9 bar the temperature was 20 degrees C. So as you increase the pressure, the outlet temperature is increasing, right? So the outlet temperature, let's say when you have the temperature of 20, pressure of 20 bar, then the temperature is about 60 degrees C. At 20, sorry, 62.5 degrees C. So this is just one example, that let's say you want to see that if you vary the compressor pressure, how the outlet temperature of the compressor is changing. That's called the sensitivity analysis. So this is just an example. In flow sheet, let's say calculate you can also calculate that, let's say, you want the outlet temperature of the condenser. If you vary the pressure of the condenser, how the if you vary the pressure of the compressor, how the temperature of the condenser is changing. You can also check that. Let me show you how can you check that, right? Let's say now we need another sense. You deactivate this one. Let's say you have deactivated that, right? Once you deactivated, now you run the results is okay. Now you have to add another sensitivity analysis, let's say S2, right? So what you want to get, you want to see that how the outlet temperature of the condenser is changing if you change the compressor pressure. Yeah, if you change the compressor pressure, how the outlet temperature of the condenser is changing. You want to see that. So again, you have to put that. For example, you have to define a variable, let's say a new variable, right? And which one you want to see? You want to see the stream. That's a stream variable. So you have to see a stream variable, and which stream? What is the number of that stream? The number is 3. So you want to see the stream number 3 and which variable? Temperature. You want to notice the temperature, that how the temperature of the outlet of the condenser is changing by varying the compressor pressure. And what's the next one? Next one is the second one. Yeah, second one. And the second one is the compressor pressure. That means that's a block variable. Which block? Compressor block. And what variable? Pressure, right? Okay. And how you want to change that? Let's say it asking that what is the change of that? The change of that is, uh, you want to change from 10 to 20 bar, let's say, and the increment is, let's say, 1 bar increment, right? Okay, it is still uh, it is still red. Why? Okay, so this is not a variable. The first one is not a variable. Variable is just a compressor pressure, right? And what we want to see, I mean, previously, let's say we have what we want to see. We want to see the results of, let's say, um, the T3. Okay. And what is T3? Stream. That's a stream variable. Which stream? Stream number 3. And that variable is the temperature, right? And then we want to change the compressor pressure, let's say P, right? Pressure P, and that is a block variable. That's a block variable. Which block? The compressor block. And what is the name of that variable? That's a pressure, right? Okay, that's completed. So tabulate, you can fill all the variable, right? And then you can reset and you can run the simulation, right? So the results available, you can see that. Okay, so if you change the pressure from, let's say, I mean, you can plot this. You select that and then you can get the results. It asks you, you want to plot between the temperature and the pressure. Okay, so this is how, I mean, if you change the pressure from 10 bar to 20 bar, how the outlet temperature of the condenser is changing. The outlet temperature of the condenser is changing from 10 degrees C to 50 degrees C. So this is how the temperature of the condenser is changing. You can see that, right? So I hope you understand some of the key features. So is it okay? If you have any question, you can ask me. Actually, there are so many options in the software. I mean, you can design and simulate one of any of the complicated plants, any of the complicated system. But obviously, this is first time for you. First, you try to install the software and you try to regenerate the results that I have generated in this class. Try to develop the vapor compression system and then try to simulate and then try to think that if you want to get some specific value, then I mean that's called the design specification. And then you perform the sensitivity analysis. You practice at your home, then we'll do some more practice in the next class.
सर आई
Right?
जस्ट वांट टू आस्क कि हम अपनी तरफ से कोई मॉडल इंपोर्ट करके इस पे काम कर सकते हैं?
कोई मॉडल इंपोर्ट करके?
यस सर, जिस तरह से हम आंसर्स वगैरह पे करते हैं, मॉडल्स इंपोर्ट कर लेते हैं, फिर उसकी हम बाउंड्री कंडीशंस डिफाइन कर लेते हैं, ऑल दैट इस पे कर सकते हैं?
हाँ, yes, you can. Why not?
सर अगर इस पे आप एक क्लास कराते तो इट विल बी रियली ग्रेट.
No, but that depend कि उस एप्लीकेशन के लिए मॉडल अवेलेबल है या नहीं है. That's the question. Like ANSYS में, let's say कि अगर मैं कहूँ कि ANSYS में क्या वेपर कंप्रेशन सिस्टम का available है model already?
आई डोंट नो, मतलब आप इस तरह से होता है ना कि एंसिस में आप कोई, आप जैसे सॉलिड वर्क्स में आपने कोई मॉडल बनाया, आपने उसको इंपोर्ट किया एंसिस के अंदर, फिर आप CFD यूज़ करके आप कोई भी फ्लो करा देते हैं, फिर मटेरियल्स की प्रॉपर्टीज वगैरह चेक कर लेते हैं ऑल दैट। इस तरह से आप इसमें कर सकते हैं। नहीं, मैं इसे ये पूछना चाह रहा हूँ जिस तरह से हम कर सकें।
जी, yes, you can do that. Actually, at this stage, I want you to have some practice. आप उसको you apply on the vapor compression cycle. Next class में मैं आपको बहुत सारी examples करवा दूंगा जो already built model हैं, आप उसमें कैसे analysis perform कर सकते हैं, कैसे changes कर सकते हैं। लेकिन जो आपने आज की क्लास में सीखा है उसके लिए you have to install and you have to practice. ठीक है,
थैंक यू सर,
टीचर जस्ट
थैंक यू।
आपको एक गाइडलाइंस प्रोवाइड कर सकता है, जस्ट एक आपको रास्ता दिखा सकता है दैट दिस इज द पाथ एंड हाउ मच फार यू कैन गो, इट्स अप टू यू कि हाउ मच फार यू कैन गो, राइट? द रोड इज
थैंक यू सर।
ओपन। एनी क्वेश्चन?
Excuse me, sir. Can you type the MEIP and the username and password in the chat?
Yeah, that's the ID is, I mean, let me show you again. Can you see that 10.1.17.10, right? If you click on the OK, it will ask you login. Login is FME, okay? And the password is FME123, right? I mean, if you click on that and you click OK, it will ask you the password and then it will go to the I think the system is off now. Maybe that's why the server of the FME after 5 p.m. it is off now. Maybe you can access during the office timing. I showed you at the beginning of the class. You can copy from there. Okay, any question? Any other question?
Sir, also, what is the quiz syllabus? Quiz and assignment syllabus?
That's the air refrigeration cycle, right?
Okay, sir. Thank you.
Okay. Any other? All right. Then see you in the next class. Again, I would say that you install the software and do some practice. Otherwise, that's useless, and that would be very difficult for you to solve the complex engineering problem. Okay. Okay. Then see you in the next class. Take care. Allah Hafiz.
अल्लाह हाफिज़।